Hi, hello everyone. Welcome to this video. So last time we basically learned how to do wireframe, right? And how to debug our physics. Well, just basically create a wireframe for our physics. And this time we're going to go and start laying out terrain. Now for terrain, we're not going to be complete in this video. It does have some steps, but at least we're going to be able to set up the ground for terrain without the height maps. We're going to cover height maps next time, and then there is topic of terrain rendering. For now, we just want to have basically our big terrain and these boxes falling on it. For start, I'm just going to have to bring out geometry back because right now we cannot see anything. And I think it was in terrain scene, and here we're just going to render that stuff once again. Hopefully I haven't made any mistakes. Okay, here we go. It's all good. So we can just go from here and we can leave the lines because we're going to need them for reference. Just for the height map, we're going to use some randomness, right? In the next video, we're going to actually cover proper height maps. So let's get started with that. So to start with, we probably need to create geometry for our terrain, and we can just go to our geometry builder, and we're going to have another static method somewhere over here. I'm just going to call it public, and let me lower this. Hopefully it's visible here. But we're just going to have public static, and I'm going to return geometry once again, but we're just going to call it create terrain geometry. And what do we take in here? We're going to take width, right? That's going to be our x, and length, that's going to be our z axis. We don't have height here because we're going to actually use height from height maps in the future, but for now we can just say float height scale vector, and for now we're not going to use this scale factor. I'm just going to leave it here. So we want actually for our terrain to be centered around the origin. So because of that, I'm just going to create z offset, right? Which is minus length over 2.0f, and then we're going to have similar offset, so just y, start from negative, so that terrain is always centered around 0, 0, 0, right? So basically, let me just quickly explain this if something is unclear. So idea behind this is basically this, right? We have our width of terrain, we have our length of terrain, and if I didn't offset this, the center point would be probably around here, but since or better yet here, but since I offset it to negative width and length, our center is always going to be actually here. So that's what we're trying to do, just to have center always being here, right? So that's why we start at negative length, or we start over 2, right? So this is negative width over 2, and then we can say negative length over 2, right? And we just go to width over 2, right? Plus or width. Anyway, that's the idea, nothing spectacular. So I just need to clear this and then we can continue. So going from that, we're probably going to need to initialize our arrays. So we're going to have vertex count, but I just want to increase this for 1. Why? Well, because we cannot represent anything by one grid, right? We need 4 vertices at least, so we need 1 more for width and 1 more for length. So we're just going to have vertex count, right? Because we need to represent it by quad. So we can just say +1 +1. Then we're going to have our array for vertices, for our positions. So it's just going to be vertex count, right? Array times 3, y3, because we have x, y, and z for our position. Similar for colors. We can say new float and then vertex count times 4, y, RGBA, right? For color, and then for texture coordinates, you can already assume we have times 2 because we only have u and v for texture coordinates. So text coords, and this is a good suggestion. Then we're going to have our indices, and if you remember, we used short for indices. So that's 6 time, right? Because we have to represent a quad with 2 triangles, and 2 triangles will have 6 indices. Okay, here are just some variables that we're going to use: colon index, text code, and then indices. All right, and then I don't need this for now. So we can just go from our length, right? This is less or equal. So here it's important that it's less or equal because we're adding 1 here, right? And we need to represent quad. So then for x it's absolutely the same. For integer x equals 0, x is less or equal to width, and then we can just say x plus plus. And then we can start putting our data in. So our vertices, right, we can start writing here. And we can just say here our vertex index, right? And then x plus offset. So basically, I didn't explain this, but let's just quickly explain it. So toggle painting. So our quad in our terrain is going to be 1 by 1, right? So if we imagine our terrain being 2 by 2 in width and height, so we're going to have 1 quad here, 1 quad here, 1 here, and right here. So 1, 2, forget about this, 3, right? And if we want to make bigger terrain, we can, right? So we can have it like here. So basically our terrain is just made of 1 by 1 quads. And then we can scale it via matrix, right? Okay, so let's clear this. I always forget. Okay, shift F9. So let's just go here. We're always moving 1 unit plus this offset, right? Which sets us, if it's 64, the first one is going to be minus 32, and then it goes to 32, right? Set it around the origin. For colors, we just don't care. We're just going to fill in default white color. So I'm going to leave it here because I usually have colors in my shaders. If you want to debug something, you can leave it, but by default, we're just going to be mostly 1 by 1. And now UVs are 0 to 1, right? For entire terrain. So we're just going to always use from 0 to 1. And how can we get it? Well, it's very simple, right? So we just need to divide this x by our width of our terrain, right? Because it goes from 0 to width, right? If we normalize it, so if our terrain is 64, right? What's 64 over 64? Well, it's 1, and therefore it's correct, right? And if it's 32 here, right? It's 0.5. Right, and then we're at the middle. So, all right, same for length actually, and that's it, I think. So we can go further. So we just need to create indices now. B++ x equals 0, x is less than, oh, sorry, width, right? So here we need width, and we can create those indices, right? So yeah, so we're just going to create our indices for quad here, and we can say bottom left is equal, and now it gets a bit confusing, right? Because we're using width plus 1. Why? Because we also use width plus 1 here, right? I mentioned it cannot be just 1 by 1. We need to increase it because we're creating a quad. So that's why it's plus 1 here. And then to get it correct, right, we just need to multiply it by our row, right? We can imagine length as rows and then plus x. So I'm going to explain it right after I finish this. So we're going to have top left, which is just bottom left, then plus width plus 1. So we just increase for a row here. So basically it's bottom plus row, and then bottom right, it's just bottom left plus 1, and then we have top right, which is just top left plus 1. So let's just quickly explain this. Okay, let's paint once again. So if we imagine our terrain as something like this, right? So we need to find those indices, right? And we have bottom left, which is our width, right? Plus 1. So here, this width is entire row, right? Sorry. Yes, exactly. It's entire single row. So this is width times. So if our width is 0, right? I got confused because we need to look at z as well here. So let's just clear this because I totally got confused. So it was F9 times shift. Okay, so F9. Right, let's do it again. So we can represent row as a width times z, right? So if z is 0, we're in this row. If z is 1, right, it takes the width. So this is the width, right? These indices. And if we multiply them by z, right, being 1, so we're essentially moving one row up, right? If we multiply by z times 2, we're moving one row up. So that's how it works. So essentially, if z is here 0, we have 0, and then we have index 0, right? If x is 0, 1, 2, actually it's better here, right? 1, 2, 3, 4, etc. So top left, right here, we just increase for width, right? It's bottom left. We found bottom left. If we just add one row, we can find top left. Same, for example, here, right? If we just add one row, we're up here. And then the bottom left is very simple, right? We found, for example, index here for bottom left, and then it's here. But basically, what I wanted to mention is actually we're going like this, bottom left, find this, find this, find this, right? And then we move further, and then this one becomes bottom left. We find top left, right, by adding one row. Then we find bottom right, which is just bottom left plus 1, and then we find top right, which is just top left, right, plus 1 here. So roughly that. You can play with it to figure it out a bit. But I'm just going to go further and stay away from these embarrassing explanations. So what we need now is our triangle. So I'm just going to call it triangle 1. And we can make it of top left, for example, top right, and bottom left. So we can just do this, find our indices. So top left, top right, bottom left. And there should be, I believe, if we go top left, top right, bottom left, clockwise, I guess. That's interesting that we use clockwise. We're going to have to double check that in future. Fortunately, it's easy to change this. It's not an issue. And now the thing is, we always use the interleaved buffer. If you check here somewhere, right here, we used interleaved vertices. So we're just going to move all that to buffer that's interleaved buffer. So that means all of this needs to be merged into single array. So we can just, I'll say all interleaved. And it's going to be new float. So we need the vertex count times 9. Why 9? Let's just triple position for color and 2 for texture coordinates. Okay, perfect. Same, we create an index. We can reset these indexes that we had. And then we just have to go to our array of vertex count right here. And this is a good suggestion. So we're just increasing index, right? For each of the vertices, we get the positions. So here it's x, y, z position, then we have colors, right? And then we have texture coordinates. And then we're done here. So we just have to return geometry. Interleaved vertices. Okay, vertex count. And I believe this was uint. So we might need to cast it here. We return that vertex count, and then finally we need those indices as well. Okay, I think we're good. Actually, now that we have created that, we have to use it in our terrain scene. And then instead of geometry, oh no, not here. Actually, it's in our game objects terrain, right? Here, the geometry is not the cube geometry, it's actually terrain geometry. So as you can see, we needed this information, but here we can say create terrain geometry, and it's going to be 64 by 64, and then here I'm just going to paste 1. It's not important for now. So in theory, it should be rendered. Right? So of course, we have an issue here. It's a bit large though. Okay, scaling is the problem, right? We don't want to scale anything. So we can just get rid of those scalings, and here as well, because we're going to cover that soon. So let's just get rid of it, and let me see terrain now. Okay, I guess this is more appropriate. For now, we just used our create texture. We can leave it for now, but we're sure that it works, and it's very thin, but that's all right. That's all right. So we just now have to create a terrain body basically for our physics engine, right? Because we're still using the old one. So let's do that actually. And for that actually, we need to create our terrain. And we're not going to use box shape anymore. Actually, what we're going to use is height field terrain shape as our shape. And since here, let's just make this terrain width is 64, and then terrain, not height, but length. And we can just paste that in here. Okay, we have our geometry here. So I'm just going to break it here so that it's easier to see. But we need to actually create our height filter in shape, and you can see a lot of parameters here. We have basically height stick width, height stick length, which is just our width and length increased by 1 here. So we're just going to increase by 1 here because, as I mentioned, it's actually quad. Then we have pointer, right? Here, height field data. So that's our data to height field. So we're just going to create basically a height field, which is just going to be zeros for now. And then we have height scale, which is going to be our height scale, then min and max. So you're going to see how it works. Up axis is just going to be 1. Height data type, it's float, and this flip quad edges, I don't know what it even does, but we're going to leave it as is. But what we're going to need is this height field data. Okay, back to our geometry builder. So we're just going to actually, on our geometry, we can say public float height data, and then in our geometry builder, so we can place height data here, and And what's our height data going to be? Well, we just need to store basically y-axis in it for our terrain. So our height data, so we can say here data, and we're just going to use vertex count. We just need to store y position here. Right? So then we're going to go from in I equals to 0. Yes, exactly. For each of the maybe we can do this bit better. I don't like this notation, it's a bit confusing. But basically it's this correct. It's just fetching our y positions from here. But I think it can be done a bit more clear. So it's vertex count, that's fine, or even better, vertices length over 3, right? We just need y. And we can say here integer height data index is equal to 0. And we can increase by 3 and start from 1 for our y. And then we can say vertices I. And we can just increase here height data index plus plus. Hopefully it's a bit more clear, I don't know, but whatever. Okay, so we have that. And actually we now have to make use of it. So this is just going to be fixed. And we need pointer to it. So I'm just going to make this class unsafe because we have to work with pointers. And we can say float pointer height data pointer. Terrain geometry height data. Okay. All right. So here width, we need terrain width +1. So let's just break it into new line. We have to length. Now we need data, which is pointer, right? Integer pointer, not size, just casting, height data pointer. Then we need height scale, for now 1. Min height for now 0.5, 0.5. Okay. Pointer scalar type. Let me see. Why isn't IntelliSense working? Ah, I forgot the comma here. So here we're just going to say single, and that's a float, and then we can say false, I guess. It's complaining about something, so let's see. Here. Parameter is 1 for up axis. Okay, that's correct, mostly. Let's try to see what will happen. Okay, and there we have terrain geometry. So this is good, and we can see that overlaps quite well. This is still on our terrain, so we can add a bit of height data to it. And for that, so we're going to cover, like I mentioned, proper height maps next time, like these organic shapes. But for now, we can just introduce a bit of randomness and see what do we get and if it still works correctly. So let's start with that. And here we have height vector. So terrain scale vector. So for now, we're going to place it at 1, and then we're going to play a bit later with it. But for that, so just as an example code, we can actually introduce a bit of randomness here. So we can just say here and this is temporary code. New random, right? And then we can say our random, not exactly next because we don't care about that. We can say next single, and that's going to return value between 0 and 1, and then we just scale by our height scale factor. And if I just try it now, all right, we're sort of there, but not really, because not everything is scaled properly, right? So these lines should overlap, but they're not. And this is a bit weird. Seems at one point some of these are good, some are not. So let's try to fix that. So did there's something wrong here? Okay, here. This is for sure wrong. Okay, now it's correct. And you can see already, cubes are behaving quite correctly here, right? They're falling into this terrain. There are some bugs which we will need to iron out, but this terrain is not proper terrain, so we can play with those smaller bugs next time and see how it will behave then. And these cubes have really large velocity, so it might be just math error. But let's try to just have different scale and see what happens. So if we go to our terrain scene, and I just add for our to our terrain, and for the scale I say 5. Now you can see that it actually doesn't work, right? And the reason for that is because we have to set min and max for our terrain right here, min height and max height, and then let's just move that here. So we can say float min height, and it's not float max value, it's actually our terrain scale factor times 0.5f, but negative, right? Because we're centered around the origin, and then the max height is same. This is same as dividing by 2, right? If I just multiply by 0.5, and then we can place it here, min height, then max height, and then we have to place that scale factor here as well. So if I try it now, okay, it's sort of better. Like our terrain is not that good, but at least something. So yeah, it's all right. I guess we can leave it at 2 because this is way too much. All right, seems okay-ish, sort of. I guess it's okay. Anyway, with that said, that's it for this video. So just to recap, for our terrain, we just created basically our geometry, right? And then with that geometry, we just feed it into our pipeline that we already had, right? That's the easy part. And now the bit more confusing part is how to set it up in Bullet. And it's not hard, as you have seen. You just have to pass terrain with terrain height, then the data related to height, right? Which is just our height data, scale factor, then min and max of the height, since we're always going to be centered around the origin. If you leave it as that, you don't have like to worry about it too much. And the others are just on defaults, and that's about it. So for the next time, we're actually going to load height maps to have really nice and organic terrain. And that's it for this video. If you enjoy it, maybe like, subscribe, leave a comment, and until next time.